So, once again, does this converge or diverge? Now, this one is very weird. I have a factorial, and I have an n cubed. Now, my first thought is, what do I compare it to, of course, because I'm going to try and use the comparison test. And if I got rid of the n cubed and compared it to just n factorial, of course, this diverges. But I'm making the denominator smaller, so that doesn't really help. But like, I don't want to deal with the factorial. So to figure out something to compare this to, I'm going to change this to 1 over n cubed. And I know for certain that this converges, right? It's because it's a p series, and p is greater than 1. All right, that's cool. Let's think of, well, actually, let me start comparing. So n factorial and n cubed divided by n cubed and 1 over n cubed. This changes to 1, so definitely, well, the top, if I make the top into something smaller, then this is smaller. So actually, this doesn't help at all. Because the smaller one converges, the bigger one can do whatever it wants. It could converge or diverge. So I don't actually know. So what does that mean? It means I need to think of a different series to compare it to. I need to think of something different. Okay, so let's... what could we do? What could we do? And I already got something smaller, so I don't want to have something smaller. I guess I want to have something bigger. So the n factorial part, maybe I'll have to leave it there. So I'll leave that there. And maybe I want the factorials to cancel out eventually. So watch this. Let's see. N plus 1 factorial. This is, I'm guessing right now. I already know that if I'm going from this to a factorial, this factorial is going to definitely grow faster than n cubed. So that's something that I can think of right away, easy. And then I'll deal with this later. So let's just compare it, see which one's bigger. N factorial over n cubed and n factorial over n plus 1 factorial. All right, and maybe you'll see why I did this in a minute. Okay, let's see here. What do we have? We have, well, the tops are the same. That's great. And this, going to this, like changing to that, well, this one is definitely bigger. So if this is bigger, the whole entire fraction is smaller. Okay, now I just need to figure out, does this converge or diverge? I don't know. So let's just remember what a factorial is. I'm going to do this in red. The factorial, say if I plug in 5, that would be 5 times 4 times 3 times 2 times 1. And if I plugged in 5 to here, I would get 6 times 5 times 4 all the way down. So this part would cancel out with that, and I'd be left with 1 over 6, right? So let's think about this. I would have, now I'm just going to write out the formula for a factorial. N times n, I'm like 1 less, right? So that's n minus 1. Times another one less, n minus 2. Depending on how big n is, it just keeps going until eventually you get to 3 times 2 times 1. Okay. Now, for n plus 1, well, you start out with n plus 1, that number, and you decrease it by 1. Well, n plus 1 minus 1 is just n. And then decrease that by 1. Oh, look at that. Decrease that by 1 all the way down until 3, 2, 1. Okay, so check it out, man. This, just like we did up here, cancels out with all of that. So really, I'm left with 1 over n plus 1. Okay. Well, that's great. I already know which one is bigger. Okay, now I need to figure out does this converge? So I simplified this. So this is actually the same thing as 1 over n plus 1. Okay, I still need to figure out if this converges or diverges. I think we could use the integral test. In fact, yeah, we could, or I can do the comparison test again. Hopefully you can see how to do the integral test. But what I want to do is do the comparison test once more. So I'm going to compare it to 1 over n. Because I know this one, this is a p series, and p is not greater than 1, so this one diverges. So let's see if this helps me. And I can do this really, really quickly. This diverges. Okay, so n plus 1 became n, so this is definitely smaller than that. And if the denominator is smaller, this is something I'm going to repeat over and over again. If the denominator is smaller, the whole entire fraction is greater. This whole entire fraction is greater. And the greater one diverges. Okay, so that doesn't help us. Remember, if I have something and the greater one diverges, then the smaller one could either converge or diverge, and I would not know. So that actually doesn't help. So then what? What about this? Does this converge or diverge? I guess we could do the integral test, and that would tell me for sure. So I'm going to try and quickly do the integral test from 1 to infinity of 1 over x plus 1 dx. I hope this converges. If this, oh no. Yeah, so I couldn't do the comparison test again. So what are my hopes? This one is the smaller function, right? So I hope this diverges, actually. Because if this diverges, it's the smaller function. And if this diverges, the smaller one diverges, it pushes out the larger one. So the larger one also has to diverge. Okay, so I want it to diverge. That's great. Because u will equal x plus 1, and du equals dx. And then I have just 1 over u, du. I'll get rid of the limits of integration. I'll put it back later. So that's the natural log of u. I don't need the absolute value because I'm only going from 1 to infinity. And that's just the natural log of x plus 1 going from 1 to b, limit as b approaches infinity. So then, well, this diverges because that would be the natural log of b plus 1 minus the natural log of 2. Well, if I take the limit as b goes to infinity, remember the graph for the natural log looks like that. So as we approach infinity, the natural log just grows without bound. So then this goes to infinity, which means the integral diverges. That also means the series diverges, which means the original diverges. Oh, that was a fun one. I had fun on that one. So I'm not going to write down the answer, but I'll say it. This must diverge by the comparison test with this, which is the same thing as that. Oh, that was a fun one. I really enjoyed that. Okay, see you later. I can't see you at all.